Welcome to Joe Newton online class. In this video, I want us to discuss certain concepts in physics, and these concepts are taken from mechanics, and that is a concept of energy, work, and power. Now, without wasting time, what do you mean by? Let's take it one by one. Energy. Let's take it one by one. Energy. Now, what is energy? It's very simple. Energy is simply defined as the ability or the capacity to do work. Now, and the SI, what is the SI unit of energy when measured as a physical quantity? The SI unit of energy is joules. It is measured in joules. In joules. Joules. So the SI unit of energy when measured or calculated is what? In joules. Then 1000 joules gives us 1 kilojoule. 1000 joules gives us 1 kilojoule. Then the next is, what are the forms of energy? Forms. What are the forms of energy? The forms of energy, or types, as some people will put it, the forms of energy. We have different forms of energy based on the sources of that energy. We have mechanical energy. We have mechanical energy. We have chemical energy. We have light energy. We have electrical energy. We have sound energy. We have nuclear energy. So, and many other forms of what? Energy. We have thermal or heat energy. Thermal or heat energy. So, and many other forms of energy we have, or types. So these are different forms or types of energy. So we are not taking them deeply one after the other, but by way of overview, mechanical energy simply has to do with energy of bodies that are based on mechanical devices, bodies that are used to operate work. That is mechanical energy. Then we have chemical energy. Chemical energy has to do with the energy resources from chemicals, like the energy content in the food we eat, the energy content in the chemical cells or battery. That is, these are chemical energy. We still have light energy. That for you to understand light energy, for example, let's talk about electrical energy. Electrical energy is the energy resources we get from electricity or moving charges. Now, this electrical energy could also the light bulbs we have, the lamps, can also tap from electrical energy and give us light. Then we have sound energy. That is energy from what? So from sound system, like your loudspeaker and so on. These are sound energy. Then we have nuclear energy. That is energy resources from nuclear sources, like nucleus of an atom and something like those things like that. Then we have thermal or heat energy. Energy we obtain from heated bodies or source of heat supply, like when you are cooking in electric stove or gas cooker. That is the thermal what or heat what energy. Now, having said this, the next thing we shall look into, critical, very important, is that of mechanical energy. There are two major forms of mechanical energy, which sometimes people make mistake to classify them as under the types of energy. They are forms or sub energy under from mechanical, and these are what? Potential energy, PE, and the kinetic energy, as we symbolize them. Now, these are two forms of mechanical energy. What do you mean by potential energy? Potential energy is the energy possessed by a body by virtue of its position. That is the energy possessed by a body by virtue of its state above the ground level, that its position above the ground level, which by implication means that potential energy of a body depends mainly on the height of the body above the ground level. That is, when a body is on the floor, the body has no potential energy because it has no height above the ground level. It is not subject to gravity because a body lying down has no influence of gravity. So, by formula, we say that PE, potential energy, equals mass times gravity times what? Height. That is the mass of the body times acceleration due to gravity times what? Height. Gives you potential energy, still in joules when calculated. Don't forget that if you're working this calculation, if the mass of the body is given in gram, you have to convert it to kilogram by dividing with 1000, because 1000 gram gives you 1 kilogram. Then if the height of the body is given in centimeter, you have to divide it by 100 to convert it to meter, because 100 centimeter make 1 meter. Good. Then kinetic energy. What is the formula for kinetic energy? And what does kinetic energy imply? It is opposite to the other one. Kinetic energy simply means the energy possessed by a body by virtue of its motion. That when a body is at work or when a body is in motion, that is, the body possesses speed. The form of mechanical energy the body has is what? Kinetic form of mechanical energy. So in that case, we cannot say that kinetic energy of a body depends mainly on the speed of the body or the velocity of the body. Look at it by the formula. Equals half mv squared. So 1/2 times the mass of the body times the speed or velocity of the body raised to power 2 gives you kinetic energy of the body. This energy is transformable. A body could transform the energy from potential to kinetic. Then, that is good. Now, let's look at the other concept. The other concept, that is work. Now, let's look at the concept of work. Now, what do you mean by work? It's very simple but difficult. Then, work is said to be done when a force is applied and distance is moved in the application of the force. That is, when force is applied to a body and the force moves the body through a distance in the direction of the word force, then we say that work has been done. So that is it. What does it imply? If you apply force to a body and no distance is moved, even an inch, then you have not successfully done any work on that body. So for work to be done on a body, force must be applied, and that force must move the body through a distance, no matter how small, in the direction of the word force, not in opposite. Because when there is a countering force that opposes the applied force, then work will not be achieved. That is it. Okay. Then quantitatively, we can also define that work is the what? The product of what? Applied force and the displacement or distance in the direction of the force. So that work can also be put or work done. I mean, work done can also be defined as the what? The product of the force applied and the distance moved in the direction of the force. Mathematically, we have that work done equals what? Force times S. F is the force, where S symbolizes the displacement or distance in the direction of the force. That is it. The SI unit of work is also what? Joules. It's also joules. Then we now have another formula. Now, what if the work is done under gravity? Then under gravity is a special case. Under gravity, then work under gravity, that is under gravity, when, for example, when you are climbing staircase or when you are moving from staircase up floor down, or when a body is thrown up or released from a height, or when somebody lifts a bucket or a bag of cement up to his head, that is work done under gravity, because those activities are subject to force of gravity. So in that case, the work done is equivalent to potential energy by formula. So it equals to what? mgh. So it's equivalent to this. That is it, under gravity. Yeah, because the work activity of that work is subject to force of gravity. Then, again, when work is done with an under inclined body, is force. Then this is the horizontal component of the force. This is theta. This is the point of application. Now, what if you use something like a rope to drag a box, or like any body, any object? When we say body in science, we mean any object. Use a rope to drag it or tow it like that. Horizontal movement. This is the horizontal distance, and this is the force applied. Now, you have to get the effective force in the horizontal distance, which is in the horizontal direction or horizontal component of the force, which is vector resolution. In that case, you can see that the effective force there is what? The effective force there now, the F net here, or the effective force in horizontal direction is equals F cos theta by vector. So if this is the case, then the work done now will now be what? Equals F cos theta times distance, times this distance. So the F cos theta times the distance gives you the work done under inclined movement to the horizontal, under angle, with angle inclined to the horizontal. So in such case, this is the formula we are going to use. So be mindful of this formula. Be mindful of this formula. Then look at this one. Look at this one. Then That is it. Then let's look at the next concept quickly, which is what? Power. But don't forget, the unit of work is also joule. Then power. Now, what is power? Power. So I told that these concepts, they have distinction and they are also related. They have relationship between them. Now, power is the time rate of doing work, the time rate at which energy is utilized or consumed or dissipated or expended. So power is simply defined as the time rate at which work is done or at which energy is what? Utilized. That is power. Now, from the definition, the formula could be very simple. We cannot say that power equals work done over time taken or energy over time. As it remember, our E is energy, our W is work done. So power equals to work done per unit time or energy dissipated or expended per unit time. Now, by unit, the unit of power, the SI unit of power is watt. Watt. The SI unit of power is what? Watt. And we should recall that 1,000 watts gives you 1 kilowatt. 1 million watts gives you 1 megawatt. I repeat, a million watts gives you 1 megawatt. That is why we talk about the rating of our electric lamps or bulbs in watts, 60 watts, 100 watts, 200 watts, and so on. And that's why I talk about the required quantity electric supply by power holding companies in megawatts. Good. So I think at this point, we are going to stop here so that next time we now delve into calculation examples of calculations in this, where we apply this formula. Thank you so much for your attention to this particular class. For more of this in physics and mathematics, you kindly subscribe to my YouTube channel and then like my page on Facebook, follow me on Instagram, even in TikTok. Then, if you now desire extra classes as exams are around the corner, SSC like WAEC, JAMB, NAPTEP, and NECO, all these exams coming up. So if you desire my guidance or tutorials online, so I hold online classes. Simply reach out to me. So I will be holding Zoom classes through Skype or Telegram, the social media platform. So because distance is no longer a barrier in this dispensation of the first century education. So thank you and God bless you. I remain Joe Newton online class.